Let's talk about what? Simple harmonic motion. When we are talking about simple harmonic motion, what should come to your mind? The first thing that should come to your mind is what is what? Simple harmonic motion, which is what? SHM. Now, simple harmonic motion is basically what? The movement is the periodic what? Movement of an object. Is the periodic what? Movement of an object from its equilibrium position back to its equilibrium position. From its equilibrium position back to its what? Equilibrium position. So basically, the object is moving what? Periodically to and fro. It's moving what? Periodically to and fro. Let's take an example. An example is our simple pendulum that we did back then in secondary school. Now, the simple pendulum practical which we did was we had a rope tied to a pendulum ball, and after displacing the pendulum ball, you saw the pendulum ball moving what? To and fro. Moving what? To and fro. So that's a good example of what? Of a simple harmonic motion. In today's class, our concentration is the equation of what? Of a simple harmonic motion. When we are talking about simple harmonic motion, there are two parameters which we need to note. The first one is the force which you apply and the displacement of the body. The force which you apply and the what? Displacement of the body. So basically, variables which you are supposed to see when talking about SHM is what? We are simply saying what? Force which you apply is directly proportional to what? Our displacement of that simple pendulum. Are we together? Now, elementary maths, when we want to remove the sign of what? Proportionality, we introduce what? An equal to sign. Now, introducing an equal to sign, we have what? F is equal to what? Minus Ks, where we introduce a constant K. And what is that constant K? This constant K simply stands for what? Stiffness. So basically, the parameters here are your F here stands for what? Your restoring force. Your restoring force. Your K simply stands for what? Stiffness. Stiffness. Now, if you are not hearing stiffness, you'll be hearing what? Spring constant. Spring constant. Spring constant. Now, we have another variable here which is called what? S. Now, the S parameter here simply stands for the displacement of that what? Object. So basically, your S simply stands for the displacement. The displacement of object. The displacement of that object. Now, somebody will ask me, why do we have the minus sign here? Why you have this minus sign here is because the force is acting against what? The force of the what? Of the displacement of the what? Of the object. The force of the displacement of the object. And what's that object in particular? Is the pendulum. Are we together? So basically, from our elementary physics, we know that when we are talking about force, force is basically the product of what? Mass and acceleration. So basically, recall, we said force is equal to mass times what? Acceleration. So basically, we can call this equation 1 and we can call this equation what? Asterisk. X1. Let's call this equation X1. If we take equation X1 into equation 1, if you take sub what? X1 into what? Equation 1. Now, if you do that, we simply have, in place of F, we have what? MA. So we have MA is equal to minus what? Kx. Now, we have minus Ks here. In our elementary maths, you see that when we have a minus sign after your equality sign, you take that parameter towards the what? MA. Now, if you take this parameter back to this MA, you are simply what? You are simply adding what? MA plus what? Ks. Because your minus is what? Crossing an equality sign. So basically, this is what? MA plus Ks, and we are equating it to 0. Let's call this what? Equation 2. Now, the next thing is what? We are seeing mass, and we are seeing what? Acceleration. Acceleration is the parameter that constitutes of what? Velocity and what? Time. So basically, recall that acceleration is the what? Is the change in what? Velocity divided by what? Change in time. Now remember, velocity is another parameter on its own that has what? Two parameters involved when we are talking about velocity. And what's that? Velocity is also The change of what? The change of displacement over what? The change of what? Time. This is acceleration and this is velocity. Now let's call this asterisk S2 and let's call this asterisk what? S3. Now, we have this equation 2 to be what? MA plus what? KS equal to 0. Now let's take this up here. So basically we have MA plus KS equal to what? 0. Now we are seeing acceleration here. And what do we say acceleration is? Change in velocity over what? Change in time. So basically this is MA, this is what? M. We are replacing acceleration with what? The V over what? The T plus Kx equals to Z. Are we done? No. We are not done. We are seeing what? Velocity. We are seeing what? Velocity here. And you know velocity is another parameter in school. So basically velocity here is what? Change in what? Displacement over change in time. So basically what we have here is what? M multiplied by D over what? Dt. And what is velocity? Velocity is what? The S over what? Dt plus Kx equal to what? Z. Now we can call this what? Equation 3. So basically this can multiply what we have here. If this is multiplying what we have here, we simply have that M the square S over what? Dt square plus Ks equal to 0. This still remains our equation 3. So there is no need to reduce it to be what? Equation 3. Now the next thing is, we have a second differential here. We have a constant and a variable S, which is displacement. What we do is, let's make your differential stand alone. Now if you want to make this differential stand alone, you are going to divide through by what? M. So we are having what? We simply divide. We divide through by what? M. Now, if we divide through by M, we are simply having what? M the square S over what? Dt square divided by what? M plus Ks divided by what? M, and this is equal to what? Z. Now if you look at what we have here, we have M and N, same parameters, and they are what? And they are dividing. So basically this can cancel out what we have here. K cannot cancel out M, and this is equal to what? Z. So let's rewrite this to be what? The square S over the T square plus K over M S equal to 0. Now, we are now having our second differential to stand alone. We are having a parameter, a variable K dividing what? M, and this is equal to 0. So we can confidently call this what? Equation what? 4. From our elementary maths, we know that when we have dy over dx, this is represented as what? Y prime. If we have dy square or the square y, if we have the square y over the x square, then we can represent this as what? Y prime prime of what? X. Are we together? So we can represent this as y prime prime. We can represent what we have here as what? Y prime of what? X. Are we together? I also rewrite this as dy over the x is equal to y dot of what? X. Now for the second differential, when we have the square y over what? The x square, this can be written as what? Y dot of what? X. Are we together? So let's apply this concept, the second concept, to what we have here. Here we are having what? The square x over the t square. So let's apply this concept, meaning we are applying what we have here. So if we apply what we have here, this will basically give us what? This will basically give us x prime prime or x dot of what? T, because this is what we are differentiating with respect to, is our time. Now, plus, you take down your plus, what do we have? K over M of what? X equal to 0. We can see all this equation fine. What we have here is what? K over M. Remember, we can represent K over M as what? Angular what? Velocity. the square of what? Angular velocity from our elementary physics. Now, but we know that W square is equal to K over M. Now, if you apply this concept here, meaning we are representing K over M with what? W square. Are we together? Now, if you do that, we simply have your x dot dot of what? T plus W square x is equal to what? 0. This is our second differential. We are differentiating with respect to time. Your W square simply stands for your stiffness divided by what? Your mass, which is what? W square is equal to 0. Now, basically, this is what? The equation for what? Simple harmonic motion. Are we together? So this is what? The equation for simple harmonic motion.